Hello friends, welcome to Kranthi physics tutorials. Okay, so today we have to discuss about the very most important question in your second year physics. In your second year physics, that is Kirchhoff laws or Kirchhoff laws. Okay, so Kirchhoff laws or Kirchhoff laws. So whatever it may be. So Kirchhoff is a scientist name. So today we will discuss about the Kirchhoff's first rule and Kirchhoff's second rule. So Kirchhoff's rules and Wheatstone bridge. So these questions are most one of the most important questions in your entire second year textbook. Okay, so let's we start now. Okay, so Kirchhoff laws. So Kirchhoff's law. Kirchhoff's laws are rules. So what Kirchhoff we can say like that Kirchhoff rules or Kirchhoff laws. So here Kirchhoff's first law is called as junction rule. Junction rule. The first one is the Kirchhoff's first law is the junction rule or Kirchhoff's current law. So Kirchhoff's first law is called as the junction rule, Kirchhoff's junction rule as well as Kirchhoff's current law. Kirchhoff's current law. Okay. So what is junction rule or what is Kirchhoff's current law? Now we will discuss. So for example, if a junction point is there, so some of the currents are entering into that junction and for example I1, I2 currents are entering into a junction point. I3, I4, I5 currents are leaving from the junction point. Now how we can calculate the total current at this junction? So that is stated by the Kirchhoff's, stated as the Kirchhoff's first law, that is called junction rule. So Kirchhoff stated that the number of currents entering into a junction is equal to the number of currents leaving the junction. The number of currents entering into a junction, the number of currents entering into a junction is equal to the number of currents leaving the junction. The number of currents entering into a junction is equal to the number of currents leaving that junction. So this is the statement of the Kirchhoff's junction rule. So already I told you electric current. Here you must and should remember one point. Electric current is not a vector. Electric current is not a vector. Electric current is a tensor. Electric current is a tensor. Electric current is a tensor quantity. So electric current is a vector. Electric current has magnitude as well as direction, but it does not obey the vector law of addition. It does not obey the vector law of addition. It does not obey the vector law of addition. So here I1 is a vector. For example, if electric current is a vector, I1 is a vector, I3 is a vector, then we need to take a resultant vector. But here the electric current is not a vector quantity. Electric current has direction, electric current has magnitude, but it does not obey the vector law of addition. So that's why electric current is a tensor quantity. It is not a vector quantity. So tensor quantities are, so how we can add them? Just normal in algebraic sum. So algebraic sum. So we can add the tensor quantities are just like as a normal algebraic sum. So that's why here the number of currents entering and the number of currents leaving from a junction, so can be added as a like a normal algebraic sum. So why? Because the electric current is a tensor quantity, it does not obey the vector law of addition. So that's why, so we can't add them as a vector addition. Only we can add them as a like a normal algebraic sum here. So you must and should remember. So please comment below. So the example for a tensor is one of the quantities electric current. So you can mention the other quantity, tensor quantity. So example for a tensor quantity. So you can comment in below. Okay. So now the number of currents entering into a junction is equal to the number of currents leaving the junction. So how many currents are entering? I1 plus I2. So how many currents are leaving? I3 plus I4 plus I5. So that's why I1 plus I2 is equal to I3 plus I4 plus I5. So the total number of currents entering is I1 I2 is exactly equal to the total number of currents leaving that junction. It is I3 plus I4 plus I5. So here if we can take the RHS side quantities to the left side, LHS side. So how we can write I1 plus I2 minus I3 minus I4 minus I5, it is equal to 0. I1 plus I2 minus I3 minus I4 minus I5, it is equal to 0. So using this equation we can stated Kirchhoff's junction rule in another words. So what is that statement? The algebraic sum of the algebraic sum of the currents, entering and leaving, from a junction is equal to 0. So we can stated the Kirchhoff's junction rule in two different terms. So one is the number of, here two statements are there for the same law, junction rule or Kirchhoff's first law. The number of currents entering into a junction is equal to number of currents leaving from that junction. In another words, we can say that the algebraic sum of the currents entering and leaving from a junction is equal to 0. So this is the Kirchhoff's first rule. So whenever in any circuit, so if there is a junction point is there, so then how we calculate the current at that junction? So the number of currents entering into the junction can be taken as positive. So entering currents can be taken as positive, and leaving currents. So leaving currents can be taken as negative. So here the Kirchhoff's junction rule so gives us, so how we can take the sign convention at a junction point. How we can take the sign convention? So the entering currents can be taken as positive and leaving currents can be taken as negative. So that is about the Kirchhoff's junction rule or Kirchhoff's current law. So here at any junction, so the Kirchhoff's said that, so how we can calculate or how we can take the sign convention of the currents. So in this Kirchhoff's rule, Kirchhoff's junction rule, Kirchhoff's stated about the current. So that's why this law is also called as Kirchhoff's current law. So very simple. So Kirchhoff's stated two laws. So in that, first one is the Kirchhoff's first law is the junction rule or Kirchhoff's current law. So whenever in a circuit, if a junction point is there, so then how we can calculate the current at that junction point, or how we can take the sign conventions of the current at that junction point, or can be stated by the Kirchhoff in this junction rule. Okay, is it clear everybody? Okay, so thank you.